Hello students, welcome back. We hear a lot of sounds in our daily life. We hear the sounds of footsteps from vehicles and from musical instruments. Let's learn how these sounds are produced and how it travels. The to and fro or front and back motion of an object is called vibration. That means if an object starts from here, goes till here and comes back to its original position. This is one vibration. Sound is produced due to the vibration of an object. Let's learn it through an experiment. Take a rubber band and put it around a pencil box. I fixed two blocks, one on each side of the pencil box. I am plucking the middle of the rubber band. Here you can see the movement of the rubber band, that is called the vibration. And you can hear a sound. The sound is produced due to the vibration of the rubber band. When it stops vibrating, we cannot hear any sound. You can do another experiment. Take a metal plate, pour water in it, and now strike the rim of the plate with a metallic spoon. You can see ripples on the water or waves on the water. This ripples is produced due to the vibration of the plate, and we can hear the sound. From these two experiments, we can conclude that a vibrating body produces sound. We can hear sound from musical instruments due to the vibration. For example, in sitar and mridangam, when we pluck the string of the sitar or when we beat on the mridangam, then the string starts vibrating. Due to this vibration, the sound is produced. Have you heard of jal tarang? I have placed 6 tumblers here and filled water in all of them, but at different levels. The level of the water increases from one end to the other end. And when I strike these tumblers with the metallic spoon, I can hear a pleasant voice. This sound is produced due to the vibration, and the frequency of the sound increases as the level of the water in the cup increases. The principle behind jal tarang is that when we strike the tumbler with a metallic spoon, it starts vibrating and it travels into the water and it makes the water vibrate. When this vibration transferred to the atmosphere, the surrounding air molecule starts vibrating, hence the sound is produced. As we now know how the sound is produced by the object due to its vibration, let's learn how we produce sound. Humans produce sound by larynx. When you swallow, just touch your throat with the finger. You can feel a hard bump moves, that is a voice box. This voice box contains 2 ligaments. They are called the vocal cords. These are the vocal cords. When we are silent, these vocal cords are relaxed and they are separated. So air can pass through it without making any sound. But when we speak, these vocal cords come close to each other and it gets stretched. Because of this, only narrow space is there for the air to pass through it. When air passes through this narrow slit, it vibrates the vocal cords. Due to this vibration, the sound is produced. These vocal cords are attached to muscles which make them tight or loose. The length of vocal cord in males is between 1.75 cm to 2.5 cm. The length of vocal cord in female is 1.25 cm to 1.75 cm. But in children, the length of the vocal cord is very small. Due to this, we all produce different sounds.
Sound needs a medium to travel. It can be a solid, a liquid, or air. Let's learn how sound travels through air. When a bell rings, it vibrates. These vibrations push the air molecules surround it. Those air molecules then push against the adjacent air molecules and hence the sound moves. Sound decreases as there is a decrease in the amount of air. If a bell rings in a vacuum room, we cannot hear any sound. The sound travels in liquid 5 times faster than in air. If a bell is ringing below water and we are above the surface, we cannot hear the sound much. But when we go underwater, we can hear the sound much louder. When we are above the surface, the sound waves vibrates our eardrum, and when we are below the water, our whole head vibrates along with the sound. Now, sounds travel through solids. You can place your ear on one end of a wooden table and ask your friend to scratch on the other side of the table. You can hear the sound of the scratch very clearly. Hence, we can conclude that sound travels through solids. In fact, sound travels through solids very fast and less in liquid and least in air. We know that in solids the molecules are very tightly packed, and in liquids the molecules are not tightly packed as solids, and in gases the air molecules are loosely packed. That is the reason sound travels faster in solids.
Let's learn how the structure of the ear helps us to hear. The outer part of the ear is called pinna. Sound enters through this pinna into a canal. This canal is called ear canal. And on the end of this ear canal, there is a circular membrane that is called the ear drum. This ear drum is stretched tightly. We know that the sound waves are vibrating. When these sound waves are vibrating, it makes the eardrum to vibrate. Eardrum passes this vibration into the middle ear. This area is the middle ear. And in the middle ear, there are three small bones present. That is malleus, incus, and stapes. These sound waves make these three bones to vibrate. These bones amplify the sound waves or increase the strength of the sound waves, and these sound waves then pass on to a structure called the cochlea. This is the cochlea. It is a snail-shaped structure with fluid inside it. And when cochlea vibrates, it makes ripples in the fluid and a traveling wave is produced. This traveling wave finally sets up an electrical signal in the auditory nerve. Here, auditory nerve is there, and this traveling wave produces stimulus or electrical signals in the auditory nerves, and this auditory nerve passes this information into the brain. Now we get the sensation of hearing. Now let's learn about some new terms: amplitude, time period, and frequency of vibration. We know that the to and fro motion of an object is called vibration. That means if an object starts from this position, it comes till here and moves back. That is called one vibration. Vibration is also called oscillation, but oscillation is a little bit slower than vibration. Vibration is very fast. We can understand this through one experiment. This is a pendulum. And the pendulum consists of a 1 centimeter thread which is suspended from a support, and on the other side of the thread there is a metal ball. This metal ball is called the bob. When the pendulum is at rest, that position is A. That is the central position of that object or that pendulum. And when we touch the pendulum, it starts oscillating. It oscillates from B to C. And the displacement of the central position to its extreme position, that is called the amplitude. That is the displacement from central position to one of its extreme position. That is called the amplitude. Amplitude is the maximum displacement of a pendulum or a bob from its central position to either side. Now let's move on to frequency. Frequency is the number of oscillations made by an object in 1 second. In 1 second, how many times an object oscillates? That is the frequency of an object. This frequency is denoted by F, and the SI unit of frequency is Hertz. Hertz is named after the scientist Heinrich Hertz, who first broadcast and received radio waves. For example, consider an object oscillates 20 times in 1 second. That means the frequency of that object is equal to 20 Hertz. 20 times it oscillates in 1 second. Now, time period is the time taken by an object to complete one oscillation. It is denoted by capital T. Let's consider an object oscillates 20 times in 1 second, that is frequency is equal to 20 Hz. And consider that the time taken for these 20 oscillations, time for 20 oscillations is equal to small t. Now let's calculate the capital T, that is time taken for one oscillation, that is equal to small t divided by 20. This 20 is the frequency, that is small f, that is equal to t by f, that is small t by f. Time period is equal to 1 by f, that is time period is inversely proportional to frequency. Now let's learn about the characteristics of sound. Loudness is one of the characteristics of sound. Loudness depends on the amplitude of vibration. Amplitude is the distance from central position to one of its extreme position. You will get more clarity through one experiment. Take a metallic tumbler and a metallic spoon and take a small thermocol ball and tie it with a thread suspended from a support so that the thermocol ball touches the rim of the tumbler. Now gently strike the tumbler with the spoon. We can see that the ball is pushed away to a small distance. That means the amplitude is small. Amplitude is small. And we can hear only a feeble sound. Now,
Strike the tumbler with more force.
then we can see that the ball is pushed away to a longer distance. That means the amplitude here is large. And we can hear a loud noise. From this experiment, we can conclude that when amplitude is small, the sound is small. And when amplitude is large, the sound is large. This loudness is denoted by dB, that is decibel, is denoted by dB. And the loudness is equal to square of the amplitude. Loudness is proportional to square of amplitude. That means if amplitude is 2, then it is proportional to 2 square. That means 4. The loudness is 4. Loudness is proportional to square of amplitude. Another characteristic of sound is the pitch. Depending on frequency, sound is classified into two: low pitch sound and high pitch sound. Frequency is higher, pitch is higher. Frequency is lower, pitch is lower. The frequency is the number of oscillations per second that we know. So, if the frequency is lower, the pitch is lower. When the frequency is higher, pitch is higher. Can you think of a high pitched sound? The sound from a whistle is a high-pitched one, and mostly the sound of woman is high-pitched. The low-pitched voices only vibrate the eardrum with a lower frequency. Examples of low-pitched sounds are the sound or roar of a lion and the croak of a frog.
Let's learn about the audible and inaudible sounds. All the sounds are not audible to humans. The sound of frequencies less than 20 Hz, that is 20 oscillations per second, cannot be detected by human ear. Similarly, the frequencies higher than 20,000 Hz, that is 20 kilohertz, cannot be detected by human ear. Humans can hear the frequencies between 20 Hz and 20,000 Hz. The frequencies less than 20 Hz are known as infrasonic sounds or infrasonics. Animals such as elephants, whales, and giraffes produce these infrasonic sounds to communicate with each other over long distances. Earthquakes and volcanoes produce infrasonic waves. The frequencies higher than 20,000 Hz, that is 20 kilohertz, is termed as ultrasonic sounds or ultrasonics. Bats produce ultrasonic sounds. When they produce these sounds and it hit a prey, it comes back to the ears of bat and it can detect the prey and can hunt in the night. Ultrasonic sounds can be detected by dogs. Police use high frequency whistles which dogs can hear and humans cannot. In medical field also, ultrasound scanners use these kinds of ultrasonic sounds.
Now let's learn the difference between noise and music. We hear a lot of sounds in our daily life, but all sounds are not pleasing for our ears. Do you like the sounds from a construction site? It is very irritating. Like that, if you all talk together in the class, your teacher will say that, oh, what a noisy class, right? These unwanted kinds of voices, sounds, is termed as noise. If someone sings melodiously, he produces a musical sound. And the sounds from musical instruments are also pleasing to our ears. If our atmosphere is filled with excessive unwanted noise, we can consider it as a noise pollution. Like the noise from vehicles, factories, crackers, and loudspeakers, they all create noise pollution. Let's learn what are the harmful effects of noise pollution. Lack of sleep, hypertension, that is BP, anxiety, and if we are exposed to the loud sounds for a longer period, permanent or temporary impairment of hearing will happen. We can take some measures to limit noise pollution. The vehicles, industrial machines, and home appliances must be installed with silencing devices. Noisy industrial operations should be set up away from residential areas. Limit the use of horns in vehicles. TV and music systems should be run at low volumes. Now let's learn what is hearing impairment. Some people born with very poor hearing. The people with very poor hearing is said to be deaf. Deaf persons communicate with each other by the signs of hands. Sometimes temporary impairment happens due to some infection or injury or old age. These persons can use a hearing aid for the more clarity of hearing. This hearing aid consists of a microphone. It receives sounds through the microphone which converts the sound waves into electrical signals and sent to an amplifier. This amplifier will increase the strength of the signals and send to a speaker, and through this speaker the person can hear clearly. Before we go to the assignments, let's do a recap. In this video we learned that sound is produced due to the vibration of an object. We humans produce sound due to the vibration of the vocal cords, and sound needs a medium to travel. It travels through solid, liquid, and gases. Sound travels fastest in solid, less in liquid, and least in air. Sound has amplitude, frequency, and time period. Amplitude is the maximum displacement from its central position. Frequency is the number of oscillation made by an object in 1 second, and time period is the time taken by an object for one oscillation. Now we learned about the two characteristics of sound, loudness and pitch. Loudness depends on amplitude and pitch depends on frequency. There are two kinds of sounds, infrasonic sounds and ultrasonic sounds. We can hear frequency range between 20 Hz to 20,000 Hz. The frequencies of sounds less than 20 Hz is termed as infrasonic sounds, and frequencies of sounds more than 20,000 Hz is termed as ultrasonic sounds. Then we learned the difference between noise and music. And we learned about noise pollution, what are the harmful effects of noise pollution, and how we can control the noise pollution. If you like this video, please share it with your friends. If you have any queries, put it in the comment box. Thank you.